Okay, so welcome back, and now we're going to talk about areas of oblique triangles. So how do you calculate the area? Well, in general, we know that the formula for the area of a triangle is what? 1/2 base times height, right? Well, the height of an oblique triangle is determined by the altitude, right? And remember, well, I'm just going to get to that in a minute. So let's draw the altitude for each one of these examples. So here I have this triangle. So I draw the altitude like so. And then here, the altitude is going to be from here down here. And I'm going to expand or extend the base. Okay. Now let's put this together. So A, B, C, A, B, C, and so this is going to be H. This is going to be C. This is going to be B, A. So again, A, B, C. Oh, and this is H. Okay, so now H represents the altitude, the height of the triangle. And so now, how do we form that formula in terms of an oblique, when dealing with an oblique triangle? Well, let's look at this one here, okay? So how do we find the height of this triangle here? Well, the height, as we've seen before, before we get to that, well, let's talk about the angles, right? So if we talk about angle A, right, how do we get angle A? Well, we know that angle A, sine of A is equal to what? Opposite over hypotenuse. So that would be H over C. And so what does that tell us? That tells us that what? H is equal to C times the sine of angle A. And so then from there, now we've got the height. We know the base is B, right? Because the altitude always forms the height of the triangle perpendicular to its base. So we know that the area then in this case, dealing with an acute triangle, is area equals 1/2 base, which is B, times the height, which is C sine A. Or, in other words, 1/2 BC sine A. Okay, so now, what about in the oblique, no, or not the oblique, but the obtuse triangle? Well, now, notice that we have to draw the altitude outside the triangle, perpendicular to the base when we extend it out. So in this case here, we're going to, instead of angle A, we're going to use this angle here, which is the complement of A, or excuse me, the supplement of A. Okay, so we'll call it A prime. So A prime is equal to 180 degrees minus A. Okay, so now, with that in mind, what we can do is we can find the sine of this angle, A prime. So we know the sine of A prime is equal to what? H over C. And so we can define H equal to sine, excuse me, C times sine of A prime, the supplement of A, okay? Or if you want, you could write it C sine of 180 degrees minus A Okay, so now in this case, our formula would be area is 1/2 base B times C sine 180 minus A, or A prime. Okay, now, okay, so in either case, it's the same, 1/2 base times height. So now, we can, again, now notice also this is two sides with the included angle. Okay, so you know this side, and the angle between them. So notice it takes the two sides of the triangle and the angle between them to find the area. Okay, so in this case it's these two, right? Same thing, BC, and it includes the angle between them, right? So if we, again, if we do it the other way, there's two other altitudes, right? I could draw an altitude from A across from B, or I can draw an altitude from C to C. And so we can use those altitudes to come up with a similar formula. So what happens? Well, here are the formulas for finding the area of any oblique triangle. So if I just have a triangle ABC with sides ABC, then the area of a triangle, of an oblique triangle, is going to equal either 1/2 BC times the sine of A, or 1/2 AB times the sine of C, or 1/2 AC times the sine of B. Any one of those formulas will give you the area of the triangle. And again, so it depends on which two sides that you know. So as long as you know two sides and the included angle, you'll be able to use this formula to find the area. Have a great day.